Hello, my name is Paul Wu. I'm here with my teammate Nikita Lutsenko. Together, we work on Meta's augmented reality platform. Now, there are a lot of tools that AR creators can use to build really novel and interesting AR experiences, but not many of these tools can deliver a wide ranging set of capabilities and creative assets to billions of devices with both quality and speed. So in this talk, Nikita and I will share our experience building a large-scale cross-platform AR runtime, and we'll share some of the lessons that we learned along the way. We've organized this talk in a few big categories. First, we'll talk about the specific area of within AR platform that Nikita and I work on, which is AR Engine. We'll talk about what it does, some of the customers that we serve, as well as some of the use cases that are enabled. Next, we'll go deeper into how we're thinking about building products at scale, specifically along three dimensions. One, we'll hit on scale as it relates to creative functionality. Then we'll discuss more traditional definitions of scale in terms of increasing user reach. And last but not least, we'll talk about some of the investments we've made in the foundation that make both of the above possible. Let's get into it. So first, what is AR Engine? So a lot of the teams within Meta want to build AR experiences, but this requires a few different pieces of technology. For example, you need to manage device input, such as input from your camera. It also requires computer vision tracking in order to anchor things on the face, body, or even the world. And it requires advanced rendering to make things look nice and to work on the spectrum of devices with different hardware technology. Teams generally want to avoid the overhead of building all this technology from scratch, so that's where AR Engine steps in. We provide these core technologies to many of the teams within Meta. We're pretty proud to say that we power all the AR experiences across all the diverse devices that Meta operates in today. More specifically, AR Engine, we cover two large systems. The first is the runtime, which effectively powers effect logic, for example, enabling things like a programming and scripting interface for AR creators. The second piece is our renderer, which draws pixels on the screen and makes them look nice, enabling things such as a programmable render pipeline and custom materials. Our product today serves a pretty diverse set of customers as represented in this image. I'll start from the bottom. Platform integrators typically refer to Meta's family of apps and devices, such as your Instagram, Messenger, and Portal teams within the company. Consumers are the people experiencing and using those apps to experience that AR content. And of course, we also serve our creators and AR developers who are responsible for using our technology to build some of the really interesting AR content that people can see today. Now, this next slide shows a few of the examples of what's enabled by our AR technology today, and I'll just voice over a couple. So most people are pretty familiar with sharing experiences on Instagram, which tend to be very selfie focused, adding things to your face to drive virality of content. A lot of what we're seeing that is really interesting is also happening on Messenger, where people are using AR in video conferences to enhance the overall calling experience, doing things like adding custom backgrounds or doing something even more interactive like building games. Just by the numbers, we feel pretty comfortable in saying that we power the largest AR platform in the world. There are over 600 million people experiencing our AR content across the family of apps. We serve over 400,000 creators building this content. There's a lot of diversity in this creator community. Over 55% of them are female, which we feel like is pretty special. It's almost unheard of in similar technical domains. And we power well over 1 million different AR experiences on Instagram and Facebook alone. So now that we've established what AR Engine does, let's talk more about scale. As I mentioned earlier, in thinking about scale, we think about this in three rough categories. The first is around improving our existing capabilities and building new ones to help unlock your creativity. The second category is around the bring up of channels and surfaces so that people can experience this content and making sure that these services have the broadest reach possible by using the same runtime everywhere. And the third category is around the cross-platform infrastructure, where the same runtime can provide the flexibility to quickly unlock new use cases whenever the need arises. Let's go into more detail on each of these in turn, and we're going to start with creative functionality. So one way to think about creative capabilities is to think about them in terms of people-centric and world-centric. And I'll start with people-centric first. People-centric capabilities use best-in-class people tracking to anchor things on the person. For example, using your eyes to control a game, or augmenting your face for a variety of sci-fi, Halloween, or cosmetic themes, or even using your hands to control the weather. World-centric capabilities put your content into the real world using things like plane tracking and target tracking, where you can recognize real-world objects. So here are a few of my favorite examples. For example, using target tracking to bring a piece of art to life to illustrate a deeper meaning, or even augmenting a greeting card to show someone that you appreciate an extra special message. Of course, we also offer a lot of non-computer vision-based capabilities also. For example, using our platform, you can build content that manipulates audio or responds to music. Gallery Picker is another capability that allows you to personalize your content with images and videos that's found on your device camera roll. This slide just shows a fraction of the capabilities that are powered by our platform today. We really believe that the power of creativity is only unlocked when creators get to use these basically as building blocks and mix and match as they please, because only then does this provide the flexibility to take an idea that exists in your head out into the world where billions of people can experience it. And next, I'll pass it over to Nikita for the next section.
Thank you, Paul. The next topic I wanted to talk to you about today was expanding reach and how we are really building a single AR runtime or single runtime for AR experiences, but we need to serve different form factors and we need to solve a lot of hard challenges. So first, let me talk to you about ecosystem form factors. As in, where do you actually can experience a lot of these? Where do we need to serve your experiences? And this is what it comes down to. On the far left, you have mobile with family of apps. This is where we've started. This is where you've seen the most of your experiences today in Facebook, Messenger, and Instagram, and multiple other apps. But this is where the first form factor comes in. Next one, much bigger. Not as portable, desktop. Messenger for desktop as well as Spark AR Studio are prime examples of that amongst multiple others. This is where we have a much bigger display, much more advanced hardware, but it's not a portable device, so some of the AR experiences are actually, well, not available, or they're different. Third one is one of my favorite ones to build for, Portal. Portal Storytime opened up another set of AR experiences for people where you can actually tell an interactive story across a video call. You can also just use, well, face specs and smart camera on Portal devices. All of this is still built on the same cross-platform AR runtime that we actually have behind the scenes. And last but not least is VR. This is one of the first, Spark AR Player is one of the first examples there where we actually can take some of the content that is built for augmented reality into simulated mode and run it in virtual reality. This is one of the pieces there that has a completely different form factor with stereo rendering and multiple other things behind the scenes different, like controllers. This is also a target for us to solve with the same runtime. First, let me talk to you about asset optimization. As in, well, we want to deliver your experiences to all of them, and we don't really want to change assets, or we don't want to move this all the way to content creators to you. We start with creators, where the output of this is actually assets. The experiences that you create, the experiences that you publish to Spark AR, all of it comes from you. The first process that kicks in behind the scenes is actually a lot of server-side optimization. We divide it up into 3 big buckets to optimization, compression, and packaging. Let me talk to you about each one of them. With optimization, we actually can start optimizing some of the assets. Think throwing away comments from scripts or ditching empty pixels where they don't need to be there. Next one on compression, where we can start compressing the assets for the target device. So say if it supports specific set of texture formats, we'll probably convert those assets into it. Or if we actually need to down compress it to the smallest file size so we optimize for connection speed, we'll do it within the same service. Last but not least is packaging, where the same assets that you upload to us might not be actually delivered all in one lump sum. Then we'll probably not deliver the one package, but we'll divide it up into multiple small ones if the connection speed is too low and we still want to optimize for instant experience, or we can deliver it as one big package if you're on high-speed network, say on desktop. All of the assets will still be stored in CDN, and the next step that kicks in is quite interesting. Let me walk you through what happens with high-end versus low-end. So let's start talking about high-end phones or high-end form factor devices. One of the big things that we take into account is network speed. Say, are you using a Wi-Fi or even Ethernet connection, or you're really on a 3G network or 2G network for that matter. A lot of this comes down to compression and packaging, where we probably will use the smallest file size that we need to deliver on a slow network that is slower to uncompress, but on high end that's probably okay and we'll still do it. But on a fast network, we want to optimize for instant experience, but a trade-off here comes with a file size, meaning that we'll probably just use a zip file. Both fast and slow network will still get high-res assets and precise ML models. This means that ahead of time, we actually know what can we serve. If the phone or a desktop device would have a high-end display, big display, will deliver high-res assets. If it has a lot of compute power, we'll deliver more precise ML models that can do tracking much better at the trade-off of performance or speed of execution. When it comes to low-end phones, well, see, a lot of things are different. One of the big things that you've started noticing is that probably will not deliver high-res assets anymore. We'll probably do also a trade-off on precision of some of the machine learning models and computer vision models that we're using. At the same time, the high versus low connection speed, or fast network versus slow network, is still being taken into account. There's a lot of gray area in between these two, as in there are a lot of cases where we deliver precise ML models and low-res assets, or the other way around, in between the two. But this gives you some of the idea of what we can do server-side ahead of time to optimize assets. Next piece I want to talk about is optimizing at runtime. To talk about optimization, let me show you how most of our runtime works. First, we start with camera image. This is what the device camera can receive. This is what the device camera records. This is also, because our runtime is tailored for AR, one of the basic requirements that we have. Because we want to understand and know as much information as possible about what is there in the world to augment the reality, well, the first piece is to run tracking. This is a lot of computer vision and machine learning, as well as some basic tracking that we're doing. A lot of it can also come from the device built in, from the sensors that are available, but if they're not, we'll just run this built in as a machine learning model. Next one is business logic. A lot of the content is user interactive. A lot of content is different. Every experience is unique and created by all of you creators, meaning that you want to have the ability to control business logic and what happens with progression of time. This is the next step. This is where you get the information from tracking. This is where you can run scripts and actually tweak the visuals or behavior using the assets that are packaged with your experiences. Which sort of gets me to the next big bucket, loading assets. See, it's highlighted pink because it's actually really complex. Even though we're doing a lot of things ahead of time, even though we don't load assets until they're needed, they're really loaded in response to scripts, and this is really a big distinct step that is important for optimization. Last but not least is rendering. Our single cross-platform runtime is actually similar to game engines, as in it can render 3D content. It's different to game engines in big part because we don't have a built-in render loop and we're generally locked to camera. At the same time, a lot of the same technologies that go into building a modern game engine and AAA games go into building a cross-platform rendering engine here. And the output of this at the same time would be very similar to what you would find in modern games, as in it's just rendered to display. We'll also can start, of course, video recording for it. Where I was going with this is to show you what we can do at runtime to optimize performance. And for that, let me adjust some weights here. Let me show you what's the relative time difference here is. Well, it turns out that tracking and assets is by far one of the most big levers, as well as the biggest pieces that take the most time in terms of performance and really nuke our ability to optimize at runtime. You can always say, hey, but why don't you do things in parallel? You can do a lot of things in parallel in modern devices, most of them multi-core, and you'll be right, and you'll see something like this, where we can do more things in parallel, say preload assets and pre-render, as well as run tracking in parallel. But if you compare that to the most basic example that we have, one of the things that you'll realize is the core time, as in the critical path, stayed about the same. Say, if it's a pretty big experience and there's a lot of assets going on and it's using a lot of tracking, well, it still needs to do that. That time does not go away anywhere. Variability of hardware actually impacts this significantly, where we cannot optimize a lot of these pieces unless we know the target hardware performance ahead of time. This is where we're going with ahead of time optimization. We want to lower the cost of tracking assets and normalize it across a lot of different hardware, a lot of different form factors. And we want this to look something like this, where it just takes a predefined set of time. It does not take all the time. To know this, really, we need to estimate the hardware performance ahead of time to know much better what assets we need to deliver, whether we need to pick a precise ML model or not. And overall, all of these optimization are really going to, from this, which is runtime only optimized, to the bottom graph, to be ahead of time optimized. As you can see, the relative time between them is much smaller, even though the number of pieces stayed about the same. One of the big levers here is ahead of time optimization that gives us the ability to move the really important buckets and shorten the time it takes to invoke them. Next one on topic is building a cross-platform runtime, or building a cross-platform foundation for the runtime. And for me to talk about architecture of the runtime, let's first look at what we need to build for. What do we optimize for? So we want to build one runtime for multiple targets. We want to enable multiple experiences, things like sharing and video calling that you're familiar with, things like lightweight games, as well as commerce. There are multiple others in this example, but we really want to solve hard problems for all of them just once, instead of solving multiple times. On the right side, well, we have multiple form factors that we need to consider. Things like device type, say whether it's a mobile device with a small display or a desktop device with a pretty bigger display. Portal and VR go a long way. All of them are hard problems to optimize for, but we still want to do it just once. Connection speed, where a lot of our asset optimization can go in. Things like locale and language also dictate how we can deliver assets and what type of assets are delivered, as well as some of the things that we're doing at runtime. And last but not least, but probably most important for form factor, is the device hardware. Optimizing for a lot of different device hardware goes a long way, and building this just once is what we optimize for. So this means we want to build single runtime, right? Well, what are the pros and cons? Why would we want to do it? One of the core values that we get out of building a single runtime is really wide as device reach. We can give the creators, we can give developers the ability to build all of the content, all of the AR experience just once, and we can take away all of the hard work, or actually focus on the hard work of optimizing that experience to run everywhere without having to push it to anyone else. This means implicit portability of content. This means that we can deliver the same AR experience to anyone with minor change or without any change at all. Ease of extensibility. If you're building a single runtime, this also means that adding a new feature to it needs to be just once, as opposed to multiple times. There are multiple constraints to it, though. It means that none of the new features that are being added to the platform should add any cost to any existing experience, should hurt. None of the new features should hurt stability or system health. And we still need to support multi-operating systems and doing this with one runtime is pretty challenging. This leads me to the next topic, as in the architecture. What we divide up our runtime is really the same three big buckets that I talked about: tracking, scripting and model, and rendering. These are big systems. These are big buckets of a lot of code, but all of them are written just once. They have core and plugins to it, but more on that later. All of them are building on single set of OS APIs and single graphics APIs. What this means is that we were able to abstract away platform specifics, and when it comes to both operating systems as well as graphics APIs for GPUs, and make every other piece of runtime really just be written against single API. At the top layer here, you of course have an application. Our single AR runtime is a part of an existing application, and it's a feature, sometimes the frontmost one, but a lot of times it can just be a single small feature of the experience that the application provides. To go a little bit into more detail, what you'll see is we need to start building plugins. For a lot of the cross-platform runtime, we not only need to be able to build this just once, but because there are different types of hardware, different form factors, different variability of hardware and functionality available, we need to divide up our big monolithic runtime into multiple small plugins. We also need to solve things like single graphics API and OS APIs and divide those into smaller things, but there's still more of an abstraction of it. When I talk about plugins, it really goes a long way. Let me give you a concrete example. A given sharing application that is using our runtime would probably use just a small subset of plugins. They don't need to use things like multi-peer or VR controllers, meaning that they don't get a plugin. The capability that is there in the experiences actually dictates which plugins are needed in order for that experience to run. And well, an application can say, well, I don't have that plugin available, meaning that I don't need to enable that experience, or it needs to load a plugin or include the plugin inside of it in order to enable that experience. Another good example is something like video calling. Well, it probably will have a vastly different set of plugins, a lot of the common ones, a lot of the core semantics, but at the same time, things like multi-peer and remote RTC and video calling would have a completely different set of things. Building a plugin system that allows us to mix and match and declare which experiences need what is one of the core things that is encoded in the architecture of our runtime, and every application comes down to just a small set of core things of the runtime and a lot of plugins within. In conclusion, capabilities is both building blocks for creators to mix and match and unlock creativity, but it also gives us the information as well as gives us the building blocks as plugins to build within the single runtime, within the single cross-platform foundation. Estimating target hardware performance ahead of time gives us an additional lever to balance reach with quality. We can do a lot of things at runtime, we can do a lot of things server-side, but really, if we know the target hardware performance ahead of time, there's a huge set of things that opens up for us to be able to improve quality while still achieving widest reach possible. Investing in a cross-platform foundation gives you implicit portability, maximized user reach, but also, most importantly, it gives you the ability to solve hard problems just once instead of multiple times, build on top of the same abstractions and run on multiple OSs, at the same time deliver widest set of content available and all of the content being portable across different hardware. And last but not least, building for scale is really a game of inches. A lot of it is iteration, and we do not go for biggest reach or single cross-platform runtime from the get-go. We got there over time, iteratively, and we're still on looking to expand reach and still build for even wider scale with one cross-platform foundation with single AR engine. On this note, thank you for your time. Thank you for watching this presentation.